Greetings to you from the Southern California chapter of the American Statistical Association. My name is Daniel Jeske, and I'm a professor in the Department of Statistics at the University of California in Riverside. Today it is my pleasure to be the host for a podcast episode of our reading club. With me in our recording studio today is Shemra Rizzo, also a professor of statistics at UCR. Over the past few months, we've been reading a book by Nate Silver called The Signal and the Noise. Nate Silver is well known these days. In 2014, I think he was the president's invited speaker at the Joint Statistical Meeting. And prior to that, has made a lot of headlines with predictions regarding political elections.
He started with sports, right?
Yeah, I think that's where he started. I was quite impressed in the book about how much statistics he knows. You remember some of the things that he talked about, the methodologies?
Oh, yeah. It was very specific to prediction theory. He covered all the important concepts like, remember, calibration, overfitting.
Yeah, that's right. K nearest neighbors. And then he also talked about out of sample, a discussion about how if you have a sample of how many times have you driven to the store and not had an accident? It's like, 20,000 times, right? And I never had an accident. So what are the chances I'm going to have an accident when I drive home from this restaurant? Like really, really small, except for the fact that maybe now you've drunk a lot of wine or something and you're driving in a state that doesn't apply to those 20,000 trips to the store. It's a conditional probability that he's really talking about there. So he's very aware of all of these statistical techniques that make it quite interesting.
Bayesians.
He's really a big Bayesian, isn't he?
Yeah, which it was very well explained, I thought.
I like the tables that he used that kind of tried to explain very clearly to somebody that doesn't need the equations or wouldn't appreciate the equation.
I think, one of the greatest strengths of this book is how good he was at explaining all of these statistical concepts without using formulas, without assuming, very advanced math knowledge from the
That's right.
So I thought that was very impressive to explain all of this that we, as statisticians are used to talking about, this lingo that doesn't necessarily work with a layman audience. But he did a really amazing job with that.
I think that's what makes him a highly recruited speaker. He does get requests, like at the JSM meetings in 2014, to go around and talk about why prediction is so hard and what are the pitfalls of the methodologies that get used. He's able to do that in a way, and it shows in his writing, that kind of maintains the attention of the readers, even though it's a thick book, right? How many pages? Like 600 pages?
It was a big book.
Yeah.
I think it was a little bit too long.
Yeah. There were a couple chapters I didn't really like when he started talking about chess.
Right. Yes, I got a little lost in there.
And poker.
And poker. Those were very long explanations that really made me question what was the purpose of the book. The first half of the book was very straightforward.
Yes.
Very good at explaining specific concepts of prediction using specific examples. One per chapter. But then after he introduced Bayesian statistics, I thought it was going to be a second half of the book just about the power of Bayesian statistics. Right. But then he started talking about the computers and the poker and chess, and then distracted.
I know. And there's pages and pages of footnotes too, that if you take the time to go back and read them in the back of the book, you can learn more things, but it takes some time to flip back and forth. But I did like the detail that was provided. Sometimes like he would do a statistical analysis and have a footnote. So you go to the back of the book and you find out he's using like some sort of local polynomial smoothing to get his trend line. He'll say that, right? Or he'll say, I'm assuming a normal distribution and calculating a probability. So it was kind of nice to have that backup information if you want to flip back there and see what it's doing. You mentioned earlier that there's a lot of examples in the first half of the book about prediction. Which ones did you like reading?
It was very interesting to see examples that range from weather and hurricanes, the economy and politics. And obviously there were some that were more interesting to me than others. Like I really like when he talked about the flu, but also earthquakes and hurricanes. And because I think that the results of those predictions affect people's lives. I didn't care very much about the sports predictions.
Yeah, no, I like that. I did also like the meteorology and hurricane discussion. Especially, he seemed to have a strong affinity for those people. Did you catch that? The way as I was reading, it seemed like he really respects and admires how far meteorology and hurricanes have come with respect to characterizing uncertainty. He's big on that. A lot of what I read in the book is his main message to people employing prediction methods is you can't just give a point prediction, but you need to give like a prediction interval, a cone of chaos that he described for hurricanes that everybody sees on TV, right? That there's a swath that they think this hurricane is going to come. I think that might have been one of the early examples and certainly a celebrated success for giving uncertainty with your predictions, because everybody that sees that swath, they say, oh, do I live there? Then I better be ready because it's going to potentially come my way. And I think the same thing is true for meteorology because, a lot of people will now interpret like percent chance or probability that it's going to rain this weekend. They factor that into their plans.
I did find very interesting the concept of wet bias. He talked about how the people prefer to be told that it's going to rain and then it doesn't, as opposed to being told it's not going to rain and then it does. Even though the models could give you a specific probability, then the weatherman might inflate that.
That's right. Especially he distinguished between like the National Weather Service, which is a government-run organization that maybe doesn't have that wet bias in there. They'll tell you the truth. Mm-hmm. But the for-profit or the local TV news outlets, they really get into that wet bias to keep people from calling up complaining. You said it wasn't going to rain and it rained, right? Ruined my picnic. Do you remember his discussion on climatology? I found that one interesting because he talked about how we used to call it the greenhouse effect. Mm-hmm. And now nobody uses that term anymore. They call it climate change. And it really confuses the topic because everybody agrees there's a greenhouse effect. At least 94% of the scientists agree that there's a greenhouse effect. But the big debate comes about how much is man contributing to it by what we do on Earth. That cleared up to me because there's always this big controversy about global warming. But if people continue to talk about it in terms of greenhouse effect and what man is doing to exacerbate a known scientific fact, it would be a little clearer, I think, in the media.
I like that chapter because it really it provided an opinion on how something so scientific gets muddled once it's presented to the public because of the political implications and because of the lobbyists from the industries that have injected all this money.
It seems if you're a Republican, you're predisposed to think of it one way, and if you're a Democrat, you're like, where's the objectivity? Part of his book talks about what makes prediction hard. And in this particular case, what makes that hard is the small sample we have to talk about global warming, right? You only have limited amount of data to use, unlike like in a lot of applications like sports or weather, meteorology, you get data every day. But with global warming, you get one data point a year. So it's really hard in that setting to...
Plus it goes up and down, even though the trend might be going up.
Right.
It was very fascinating to me when he mentioned how in climate change research, if you make a bad prediction, that does not get forgotten very quickly.
Right.
It lingers in everyone's memory for decades. But in politics, it was amazing to me how these pundits say all these things that are totally wrong every single day.
That's right.
But then they quickly get forgotten.
In fact, you're probably thinking about his discussion of the McLaughlin group.
Right.
Yeah, on PBS. He was discussing how he checked the predictions of the McLaughlin group. I think he looked back at, I don't know, was it 1,000 predictions that they made over the course of a few years and calculated how many of them actually came true. And it was a little bit less than 50%.
Right.
Yeah, so they really aren't that more informed or knowledgeable to see the future than we are.
And the key thing there was that there is no incentive to be accurate.
That's right. It's probably more of an incentive to be controversial because that drives up ratings. If you agree with somebody that's really ranting about something, you probably want to watch them. On the other hand, if you disagree with them, you probably want to turn the channel as quickly as you can. But maybe there's enough of a base for TV pundits like that to be motivated by those reasons instead of accurate reason. Nate might have taken a hit this past political season when was forecasting, even up until the last day, that Trump only had perhaps a 30% chance of winning the general election. But I did a little checking, and I found out that actually he was better at estimating Trump's chances than anybody else. They might have had him, other people might have had Trump as low as 1%.
Well, there was this one group here, I think was the LA Times and USC poll. They
had him higher than 30%? Yes.
I think so. Definitely Nate's poll was among the ones that were the most accurate in the sense of giving Trump a larger margin.
And when you think about it, a 30% chance of something, it's not a big shock, is it, if that happens? A 30%?
It's not. I actually remember the day that we went voting, we actually had lunch together. I don't know if you remember, with the speaker. I said something like I was very happy that last night Nate's prediction said it was 70%. And he said, if you think about it, 1 out of 3 times is not that low.
Yeah.
And that made me reconsider that you were right. 30% is not that bad, right? That small, and it's not negligible. No. And then I got worried, and it was just noon.
Right. I mean, I think one way you could think about it is if you were to get on an airplane and somebody told you there's a 30% chance you might not make it if you get on this plane. Would you get on? No, who would get on, right? Because that, oh my gosh, 30%, that could happen, right? So, so I think we have to give him credit for that. But he's pretty forthright about mistakes that were made. His method is based on aggregating polls.
A meta-analysis.
A meta-analysis of polls, you're right, yeah. And actually weighting them in some appropriate way. And I also read that he felt like one of the mistakes in his methodology was that he didn't have the right kind of weighting for adjusting to events. The polls, what they say today might be different from how much weight you should put on them tomorrow if something happens in between. And the big thing that happened, of course, was Comey's letter that came out, a week before the election, something like that. And he retrospectively believes that his weighting scheme for polls didn't accurately or quickly enough reflect this blockbuster news that changed really a lot of voters that were undecided up to that point.
Do you think that polls and predictions such as this one affect the election, refeed the behavior of the voters? Would we have a different outcome if the most respectable polls had shown Trump winning, by a bigger percentage? Yeah,
so in other words, a bandwagon effect that...
Yes, would we have been more motivated to, go out and try to convince other people? Because I did think about it. I did think, should I go out and volunteer hours, calling or something like that? But in the summer, it just seemed so unnecessary because Hillary Clinton was doing so well.
I think there is something to that. And I think in his book, Nate talked about like self-canceling and self-fulfilling effects of polls, that if somebody is way ahead, people might tend to think that, I don't really even need to vote because there's so many people, much less talk to people about voting, right? And or in the disease context that you mentioned, if everybody hears, there's a flu epidemic and the prediction is this is going to, lead to expense and death, well, people probably start washing their hands more and getting enough bed rest and maybe taking their vitamins more, and then that cancels the prediction, right? So I definitely think there's something to that when it comes to making predictions, that it can change behavior. And he mentioned that also in terms of like the economists. He kind of beat up the economists for making poor predictions, right? And I think one of the problems that he has with their models is they don't handle non-stationarity very well. He also didn't think too much of political scientists when it comes. So he picks his disciplines to laud, like meteorology and hurricanes, and then he kind of beats up some of the other ones, the social sciences, psychology, political science, economics. They didn't get a lot of love.
Because they didn't get their predictions right.
That's
or
right.
They often don't.
Yeah.
So In the first half of the book, which is heavily focused on examples of the use of predictions in several areas, did you get a sense that they were mostly failures, or did you get a good balance of failures and successes?
I think it might have been tilted a little bit toward failures. Yeah.
I got that same sense.
Right.
It was a little bit sad.
Yeah.
We're told, really, that we aren't doing a very good job in most situations.
And they were quite a range of them. And one just came to mind. Even Pearl Harbor was mentioned as a failure in prediction because, nobody anticipated that type of attack. And it was the same for 9/11, right? That there were signals in both situations that were kind of missed because people lacked the imagination to say what they could lead to.
But even when you try your best, for example, in the earthquakes example, there's been so much effort over the decades, so much, brain power into it, money for the research, and we still can't predict the next earthquake.
No. We can forecast. He makes this, maybe it's a little subtle, I don't know how you feel about it, the distinction between forecasting and prediction.
Yeah.
Because he says you can certainly forecast that California is going to have more earthquakes than Ohio, but you can't say in California when it's going to happen, right? You just know in the long run, if we look over the next 50 years, there'll be more earthquakes in California. And he calls that forecasting, whereas prediction is saying specifically, within the next 2 or 3 weeks, that's the uncertainty. I have 90% confidence there's going to be. We can't do that with earthquakes.
So in the end, how helpful is the knowledge that we've gained?
I don't know. Except maybe insurance companies could use it to sell earthquake insurance. I think hurricane prediction for a while was in that same state.
Yes.
Until they had these supercomputers that can...
It's a great success story.
Yeah. I was intrigued by his phrase, a butterfly flapping its wings in Brazil can cause a tornado in Texas. You remember that one?
Yes.
Because I think that came up with hurricane simulations, like which path is the hurricane take, right? And these models, very sophisticated mathematical models, depend on initial conditions.
Right, and if you change it just a little bit, you would end up with a completely different
outcome. That's right.
Outcome.
And I think that's how you get the cone of chaos for where it could go, by twiddling with initial conditions. And I guess this phrase, which I don't know if I'd heard of before, that's kind of trying to say one small little change in the initial condition can cause something to happen that you never would expect. Like, I thought that was an interesting way of phrasing.
I think one other interesting thing that I liked he wrote is the analogy of the hedgehog and the fox.
Oh, yeah.
That was, I guess, one of my favorite parts.
You want to tell our listeners what the difference between a hedgehog and a fox is?
Well, this was based on a poem by a Greek poet, Archilochus, that said, the fox knows many things, the hedgehog one big thing. And then he interprets it in the context of prediction. From what I understood, what he meant is that you can divide forecasters into two camps, and one are the foxes and the others are the hedgehogs. And the foxes are open to lots of little facts and, I guess, pulling information from all sorts of sources, whereas a hedgehog is specialized in one thing, and maybe if it receives new information, it will try to force it into this one narrative that it has.
Yeah, and one plays to the media well because they come across so confident, right? The hedgehog. They never second guess themselves. They're always sure. It's like the McLaughlin Group people, right? They're hedgehogs because they speak so authoritatively that, people watching them could think they must be like so knowledgeable and they're so sure of themselves. Whereas the fox can maybe look a little like they're unsure, but it's really that objectivity in the fox that's being displayed there. It isn't lack of confidence. It's just being honest about what they know and understanding what they don't know.
Another layer that could be added to this analogy is where he introduced the concept of biases, and actually part of the recommendation of the book is we are aware of our own biases and try to be more objective. It could be seen as the hedgehog having very strong bias, and the fox really striving to get rid of his own biases.
Right. I don't know, you might not remember Ted Koppel, but he had a late evening news show. It was like a news magazine show, and they would delve into stories. Ted Koppel won a lot of respect for doing it objectively. And He recently was talking about how news today is much more driven by people wanting to get across their ideas. He made this comment that it's more about ideology than fact. And I think that comes up a lot with respect to people making predictions. They're really predicting what they want to have happen more than using facts and objectivity to say what could happen.
There's definitely a lot of that in the news. They're giving the same weight to an opinion than a fact. I want to talk about Bayesian probability because the whole book seemed to me to be a presentation of the current state of prediction and forecasting. And then obviously, all these things are going wrong that are being done poorly in some of the fields that you talked about. Got a lot of heat. Yeah. But and then there's this, you're left wondering as a reader, well, then what can we do to improve this state of prediction? And then Bayesian probability is presented as the solution to all of our problems.
Mm-hmm. Yeah, it does read that way. You're right.
And I think he did a good job explaining the concept, presenting it in a good light, and he did a very good job explaining the formula of Bayes' theorem without actually showing you the formula, and a little bit of the history behind how it was conceived. But I did not find that entirely satisfying as an ending for the book or as an ultimate solution for forecasting.
Right.
And I had, so my main issue with that was that he didn't actually present examples where Bayesian probability was used to have a successful story in prediction. Mm-hmm. Just like the hurricanes, that was a great example of when things go right. But I didn't get that. I didn't get an example where I felt really proud of having Bayesian statistics. Yes, I think it was a great idea to present the concept of Bayesian probability as a model to use more because it has great strengths. I just didn't think he did a good job showing us why. Yeah. And the best way you achieve that is by showing an example. Right. Which he had plenty of in the beginning of the book for showing us how forecasting fails. But then how does forecasting gets improved by using Bayesian probability? I mean, maybe he uses Bayesian probability. I think he does. But and he did clearly very well in previous elections. But it was not enough, and it wasn't even emphasized. Yeah. So I think that's where the book fell short. I felt that, I was not satisfied with the ending. Right. So I have a question for you. Now that we've read this book, Nate Silver has his profile is so high right now. Mm-hmm. He's taken this role of the public statistician. He has managed to be the voice for our field to the general public, and he's done a great job exploring all of these statistics involving predictions. But he's not a statistician, right? He doesn't have training in statistics. He's not a researcher. What do you think about his role of the public statistician? Yeah,
he's got a certain charisma to him. As I mentioned at the 2014 JSM, he filled the room in a big ballroom full of people that wanted to hear him talk. One of the things that I think statisticians who are formally trained that we're challenged by is maybe we're not really that well trained, or we don't have a good intuition about what it is to be on TV or on the radio talking about statistics. There is, with the American Statistics Association, an attempt to try to, for those interested, train statisticians to be, a bit more captivating when they talk about their work, because the messenger maybe is important. So Nate may have assumed this role as the voice of statistics because he's captivating and probably knowledgeable enough to do most things correctly, but a lot of us that work in the trenches still working on research papers that go in these nice journals maybe, but not journals that even most people outside of statistics would have ever heard of, quite frankly.
Or are able to access because we have these firewalls.
Yeah. I think a lot of times, as researchers, we write for ourselves until someday down the road, maybe one of our students or one of us, whatever the case is, actually tries to apply it to a real problem. We're not reacting to the day-to-day thing. I mean, Nate apparently updates his forecast every single day on the website, even for what some people probably think are trivial things like the probability that baseball team will make the playoffs, right? Gets updated because, baseball, you get data every day. Teams play almost every day, so it'll change. Just think how many people you can attract by doing statistics in sports. I know that isn't your favorite, right? But yet we have a journal now
for sports.
There's a lot of people that work in theoretical statistics that dabble a little bit with applications in sports. So that medium is a way to communicate with people.
I think it's been wonderful that someone wrote a book of statistics that ended up being a New York Times bestseller.
Yeah.
And that normal people read and hopefully get inspired to more involved in statistics. Because what usually happens is that it's all these fields, like the medical field and other similar fields, where they get to be in the news often, but statistics doesn't.
Yeah.
So this has been a great example of how to achieve that.
Yeah.
So my hope is that more people follow, and then we see more of statistics explained in very compelling stories to the public.
One last thing before we run out of time is I wanted to ask you, because of course you're a biostatistician and very interested in medical research and the applications of statistics to medicine. He did sort of cite medical research as one of the areas where predictions have failed. And I was wondering what your thoughts about that are.
Well, yes, he talked about how we use very simple models and how those symbols fail, once they're supposed to reflect reality. Mm-hmm. And I think that was a little depressing to hear, because it's where you really need it the most. He did have this quote about how in medicine, a stupid model kills people. So you cannot be irresponsible. So in a lot of ways, I guess that's what's also preventing certain new statistical techniques being implemented. Like we have this controversial personalized medicine, right?
It isn't the hope of that more precise predictions, right?
It is, but then you have very small sample sizes.
Yeah,
right?
And so far the pursuit of those magic features or predictors that allow you to say what an outcome if a patient was treated this way, it's been a bit elusive.
Yes, there definitely has been a lot of disappointment. But what I want to say is that in medicine, I think we will do a lot of progress in our lifetime and over time, much more than, say, earthquakes.
Okay, I'm glad to hear that.
I'm completely confident.
Good. You're a hedgehog on that one. All right. Well, thank you very much, Shemra, for participating in this podcast. It was nice talking to you, and I think we both enjoyed the book. We'd recommend it to anybody that would like to see sort of a popular treatment of prediction that isn't dragged down by all the mathematical notations and theories that one could get in with a formal treatment of prediction. It's a nice read.
Yes, thank you for inviting me.
All right, thank you.